My name is Seth Ariel Tongay. I'm the chair of the Material Science and Engineering. I'm also one of the research directors at the Fulton Schools of Engineering at Arizona State University.
My name is Candace Chan. I'm a professor in the Material Science program at ASU in the School for Engineering of Matter, Transport, and Energy.
My name is Terry Alfred, and I'm the associate director in the School for Engineering of Matter, Transport, and Energy. And I'm also a professor of material science.
Previously, many people have claimed that silicon can be replaced by this material or another one. But silicon is still here. Probably silicon is gonna be here for many decades, except we are at the crossroads.
Silicon doesn't work well at high temperatures. So everyone says, hey, why don't you build your solar panels out in the desert because you got all the sunlight? Well, the efficiency goes down as the temperature goes up, so it's not exactly the best thing.
In some cases, we're looking at completely new materials that we hope can improve the energy density of batteries, which will allow us to use the batteries for either longer durations of time. If you think about using these materials in an application like for an electric car, for instance, the higher energy densities would allow the car to drive faster or for a longer period of time before you have to recharge it.
It takes atomically thin, two-dimensional semiconducting materials. We have already identified which one of those set of materials will be impactful in new generation of devices. Some of these devices include neuromorphic computing. Some of them include ultra-scale devices that has the potential to replace silicon.
There is a report where a diamond semiconductor operated successfully in an environment similar to Venus. In this environment on Earth will never be anything like Venus. So that diamond semiconductor will last a long time. Unfortunately, diamond is not there yet. Diamond is difficult to polish. Diamond is difficult to modify because of those strong carbon-carbon bonds. And what we're looking at is how can we take not so good diamond substrates and grow better layers of diamond on top of it.
Our efforts oftentimes takes something grown at much smaller scale. We find effective ways to make these materials at much larger scales so that industry would be ready to pick up these technologies to be able to integrate into their applications.
A lot of radio frequency communication could actually utilize diamond. You will see it make a larger impact in communication, antennas, radar, especially military, and you will see it making an impact in electronics used to explore outer space.
One area of research that is very promising, and a lot of other groups are also looking at this, is something called a solid-state battery. So a solid-state battery, as you might think from the name, means that you don't have liquid components in it. So the main benefit of that is that it can allow for a safer battery, but there are also certain kinds of solid-state batteries that can also allow for higher energy densities, which will enable the electric car or whatever device you're using to last for a longer time before you can recharge it.
Arizona State University is one of the fastest growing universities in the nation. At any given direction at Arizona State University, you would be able to find any expertise that you would need. All of a sudden, it creates this truly cutting-edge research that is not very easily attainable.
I've been here at ASU since 2011. I came here as an assistant professor. Fulton Schools of Engineering was in a really large growing phase. I think I was one of the first cohort of faculty as part of that. So it was a really exciting place to be because we could see there was a lot of investment into the research facilities here at ASU, a lot of really great faculty being hired. So I have really the greatest colleagues here. So I think it's just been a very exciting place to be. And now that I've been here for a while, I can see that the trajectory is still increasing. We have the greatest students. We have a really strong dedication to the student training and educational programs. And so I think that this environment is really great for working with students and for also doing research with students.